Okay, this is extension number 3 from chapter 6, and today we're going to learn about the equation of a line. So to do that, I want you to look at this investigation. Can you graph out the following functions, number 1, number 2, number 3? And you can use the table of values if you want to get some help that way. So if I'm looking at the first one, I'll just use these values, negative 2, 1, 0, 1, 2. That was weird. Finding the corresponding y values, 4, negative 2, 0, 2, and 4. Let me plot. Draw a line. Okay, that's number 1, right? Y equals to 2x. How does that change with the next one? 2x plus 5. Use the same values. 2 times negative 2 is negative 4 plus 5 is 1. Negative 2 plus 5 is 3. 0 plus 5 is 5. 2 times 1 is 2. 2 plus 5 is 7. 4 plus 5 is 9. Do you see how it's just these values, and I'm going to add 5 to them anyways? Right? Because I'm just doing the same equation but plus 5. So let's do that. Negative 2, 1. Negative 1, 3. 5, 7, 9. Here we go. There's my equation. Y equals 2x plus 5. And finally, how about this one? 2x minus 3, the same x values this time. Let's see, negative 2 times 2 is negative 4. That's a negative then. Negative 4 minus 3, negative 7. Negative 5, I think. Negative 3. Negative 1 and 1. Okay, so negative 2, 7 down here, 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 and here. Okay, I hope you can realize that all of these lines are parallel. Interesting, eh? And so the question is, how does that b value actually change the appearance of the graph? By the way, if you think about the b value in number 1, the b value here is 0. In number 2, the b value here is 5. And in number 3, the b value here is negative 3. So if you think about what happens, hopefully you can visualize that the graph actually shifted. It shifted vertically. Okay, so there's a vertical shift. How so? Well, if the b value was bigger than 0, which way did it go? The graph goes up, right? From the black line. Okay? And if b was less than 0, notice the graph goes down. By the way, can you actually see what that b value represents here? 0. 5. Negative 3. Yes, I hope you can realize, note that the b value, I'll star this, the b value is also the y-intercept for the line. Because that is where x equals 0. Remember, if I make x equals 0, that first part of the equation just is gone, right? That's 0, that's 0, that's 0. So what you're left with, that number at the end, must represent the y-intercept. Okay. I want you to try investigation number 2 now. Do that one yourself. I'm going to ask you to do the same idea. Let's make a table of values. I'll just do the same values, negative 2, 1, 0, 1, 2. In this case, negative 2 plus 1 is negative 1, 0, 1, 2, 3. So negative 2, negative 1, 0, 1, 2, 3. Here's my line. Y equals x plus 1. Okay. Going to try the next one now. 2x plus 1. Okay, so negative 2, negative 1, 0, 1, 2. Same values. I'm going to plug it in. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. Negative 1 times 2 is negative 2, plus 1 is negative 1. 0 would be 1. 1 would be 2 times 1 is 2, plus 1 is 3, and then the last one, of course, would be 5. So let me plot those points now. Negative 2, comma, negative 3. Negative 1, 0, comma 1, 1, comma 3, and 2, comma 5. Okay, there's the line y equals 2x plus 1. Notice both of these are plus 1, right? So the y-intercept must be positive 1. And then finally, how about the last one here? This is negative 2x plus 1. Okay, so negative 2, negative 1, 0, 1, 2. Negative 2 times negative 2 is positive, 4 plus 1 is 5. Negative 2 times negative 1 is positive, 2 plus 1 is 3. 2 times 0, 0, of course, 0 plus 1 is 1. Negative 2 times 1 is negative 2, plus 1 is negative 1, and this becomes negative 3. Let's plot these points this time. Noticing this one also goes through the same y-intercept. But this time my slope is negative, right? Negative sloping line. So what do you think happens when I change the value of m? The value of m is the number in front of the x. Notice that the black is like the standard, original, and then the blue one, I guess the only difference between the equation is if I change the m value to 2. If you kind of visualize 2, do you see how many dots here? I went 1 unit to the right, then 2 up. 1 unit to the right, and then 2 up. What's that called again? Did you say slope? Well, let's just check. How about this one? This is negative 2. What does that mean? That means you go 2 down and then 1 to the right. 2 down and 1 to the right. I think that is the slope. So what change does that make? It changes the steepness of the line, which really just means the slope. And notice that if the m value was bigger than 0, you have a positive sloping line. Can't spell positive. P-O-S-I-T-I-V-E, positive slope. And if m is less than 0, you'll see that you get a negative slope, going, of course, downwards from left to right. So, this gives rise to something called the equation of a line. In general, for the equation of a line that's in this format, y equals to m times x plus b. M stands for the slope, and b represents the y-intercept. And this is known as the slope-intercept form of the equation of a linear function or line. Y equals mx plus b. Y equals mx plus b. Once again, y equals mx plus b. M stands for the slope. B stands for the y-intercept. So can we take a look at example number 1 now and start working on that? Can you state the slope and the y-intercept? Yeah, I hope you can. Slope here is equal to 5. Y-intercept just equal to negative 2. Do the next one yourself, please. Did you get this as the answer? Good. How about the next one? There's no x. So maybe you can write this as y equals 0x plus 3. Now you know the slope. Yeah. And now you also know the y-intercept. Yeah. This, my friends, is a horizontal line, because remember, 0 slope, flat line. Okay? So let's see if we can do an example number 2. It says draw the lines on the grid and then find the equations. So it says start with the point 0, 4. Well, that's nice, because that's the y-intercept. And then, what does it say now? Draw a line with slope 2/5. So remember, rise over run. I'm going to go 5 to the right. 1, 2, 3, 4, 5. And then 2 up. 1, 2. And there's my next dot. Connect them together. And, well, I didn't really do a good job. But connect them together. I wish I had a ruler. Connect them together. And there you go. There's your line. So that's part A. But what's the equation of this line? Well, we do know the slope, don't we? So y equals to m, which is 2/5, x plus, do we know the y-intercept? Yes, we do. It's 4. Done. Okay, now what about the next one? Draw a line through -4, 5. Okay, so here's a point -4, 5. And also a slope of -1/6. Okay, so rise over run. This time's not rise, but down 1 and then 6 to the right. 1, 2, 3, 4, 5, 6. Plot. And now if I were to do it, I get a line like this. Here's the answer for part B. Equation, sure. Y equals to m. That's the slope. -1/6x. Plus b. Do I have the y-intercept? Nope. Can I even find it from the graph? It doesn't look like it goes through a nice point. Problem. So how can we figure out b? Remember, we're trying to create an equation for the line. The equation actually satisfies every single point possible on that line. And so since this point is a point on that line, this is like an x-coordinate, this is like an y-coordinate, so we can plug it in to try to help us solve for b. So I'll replace y with 5, -1/6 times -4 plus b. -1/6 times -4, that's 4/6 or 2/3. And then now I have to solve for b, so b just equals to 5 minus 2/3, common fraction. I think that'd be what? Oops, not thirds. So 15/3 minus 2/3, that equals to 13/3. And so therefore, all that work to then tell yourself y equals to -1/6x, and then now we have our plus b, our y-intercept, it's the fraction 13/3. And there's the equation. So if they don't give you the y-intercept, no worries. As long as they give you a point, you can always plug it in and solve. Okay? Alright. Ooh, look at these questions. Find the slope, y-intercept. Wow, okay. So I'm thinking for this one here, there's a nice dot right there on the y-intercept. Thank goodness. That's great. 0, 3. Here's another dot here at -7. I can now find the slope. 1, 2, 3 down. 1, 2, 3, 4, 5, 6, 7. 3 down. 7 to the right. So the slope here must be, yep, -3/7. Which makes this question pretty straightforward. Y equals -3/7 x plus, what's the y-intercept again? Yeah, 3. Done. Okay. B is the same thing. Unfortunately, though, it doesn't look like the y-intercept's in a nice spot. Oh, no. But what I do see here is a nice dot here, and perhaps a nice dot there. And I can now find the run, which is 3, and then the rise, which is 4. So I do know the slope is equal to 4/3. So here I go. Y equals to 4/3 x. In this case, I need to solve for b. Now, I did tell you two points on this graph. So you can just use whichever one you want. So I'm going to use the one that's a little bit nicer. I'm going to use this point here, 1, -3. So I'm going to plug that in now. The y value is -3. The x value is 1. -3 equals to 4/3 plus b. So b equals to -3 minus 4/3. Well, that's the same thing as negative 9/3, right? Minus 4/3, which is equal to negative 13/3. And so, after all that information, therefore, our equation is y equals to 4/3 x minus 13/3. Done. Whew. So, more examples of graphing. I want you to graph. Okay? This time, however, I don't want you to make a table of values. I want you to use the idea of the y-intercept and the slope to graph this all out without actually using a table of values. Let me show you what I mean. For part A, can you first of all just identify the slope and the y-intercept for me? That's the first part. Yeah, it's mx plus b, so the m value is 2/3, and the b value is -1. Good. So really, here's what I do. I start with the y-intercept. I plot my point. Boom. And then I use the slope. In this case, rise over run. So running 3, rising 2, boom. There's another point. And then I have 2 points. I can connect the dots. If you want more points, I can do the same thing, right? Run 3, and then rise 2 again. Boom. Another dot. There you have it, friends. There's the answer to A. Okay? I'd like you to try B and C, and then we'll come back and do D and E together. Okay? But you do B and C. Go. By the way, -3 is the same thing as -3/1. So the run is 1, while the rise is -3. Okay? You're thinking rise and -3? Yeah, that means down 3. So I'm going to start with 5. Run 1, down 3. 1, down 3. And there it goes. There's your line for B. Look at that. No table of values required. If you're thinking, C, I got the slope, that's -1/4, but I don't know what the y-intercept is. Don't freak out if you don't see something there. That's the same thing as +0. So what's the y-intercept? You got it, 0. So starting at the origin, going a slope of -1, so down 1, right 4. Down 1, right 4. And now I have a really flat line that's going downwards. There's the answer to C. Did you get those? Great. Now let's do some funky ones. What about x equal -5? This is a review actually from grade 9 stuff. Hopefully you remember. This is what type of line? Yeah, it's actually a vertical line. Vertical line. Think about what this is saying. Where is x equal -5? Yeah, right here. Where else is x equal -5? Yeah, right here. Where else is it equal -5? Here. Where else? 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 Notice they're all the points on this vertical line. So that's the answer to D. Okay? Now, F. Save the best for last. Do we have to use a table of values in this one? We can. However, I think if you were to look at this equation, oh, by the way, you can use that method of doing the intercepts that we learned in a previous chapter, right? But, better yet, can we find the y-intercept and the slope? Well, I can't do it right now in this format, but if I were to actually manipulate it algebraically and actually solve for y, I might be able to do so. So to solve for y, I'm going to isolate y on the left side, and I'm going to move all the other terms, in this case the -2x, to the right-hand side, which becomes positive 2x. This is great. Now at least I have isolated y, but I don't want 3y, I want y by itself. So our last step is to divide everything, and yes, divide everything by 3. What's 6 divided by 3? 2. Ah, look at this. This looks like it's in slope-intercept form. And because it's in slope-intercept form, I can now tell you what the slope is. And I can also tell you what the y-intercept is. And therefore I can tell you how to graph this out. Point at 2, 3 to the right, 2 up. Connect together. There you go. There is F. I guess it should be E. I don't know why it says F. E or F. It doesn't make a difference. But there you go. Okay? Graphing without a table of values. I like it. Alright. Number 5 here. How do we do this question? On the grid to your right, I want you to draw a line through this point with a slope of -3. Oh, okay, and then find the equation. I thought we did something like this before. No problem, right? Okay, so 3, -1, oopsies. 3, -1, that's right there. And then a slope of -3, once again, that's rise, which is actually down, run. So 3 down, 1 to the right. 3 down, 1 to the right. Here's my very steep line, okay? And here is point P. Then the equation for this, once again, y equals to -3x plus b. To solve for b, we'll plug in the point. That's -9 plus b equals to -1, so 9 minus 1 is 8. Well, I guess I didn't draw my graph very well. Oops. Let me do it a little bit nicer. Oh, not again. Let me do it a little bit nicer. So, yeah. There we go. Y equals to -3x plus 8. There's your line. And now the graph looks much better. Okay, well, what about B then? It says draw a line through K, which is 5, 4. I'm going to plot 5, 4. Ooh, what's this word again? That is parallel to the line in part A. Parallel meaning same slope, right? So the slope in this case is -3. So the same idea. 3 down, 1 to the right. 3 down, 1 to the right. 3 down, 1 to the right. Nice parallel line through the point K. And the equation of this line, well, we know y equals mx plus b. Once again, -3x plus b. This b is off the chart, so I can't really figure it out with the graph. But what I could do, once again, is plug in the value of the point. 4 equals to what? -15 plus b. So b equals to 19. And therefore y equals to -3x plus 19. Done. Oh, one more. Oh, draw a line through K. This time, make it perpendicular to the line in part A. Ooh. Perpendicular to the line in part A. That means the slope now has to be negative reciprocal. If the slope was -3, the reciprocal of it would be -1/3, but the negative of a negative becomes positive. So let's just use positive 1/3. Now, on my graph, starting at K, positive 1/3 means going 3 to the right, 1 up, or 3 to the left, 1 down. And so this is the line here that we're looking at. This is the line for part C. And what is the equation here once again? So y equals to, you got it, 1/3, this time x plus b. Same business, let's plug in the point. So 4 equals to 1/3 times 5 plus b. I know you don't like fractions, but hey, it is what it is. 4 take away 5/3 equals to b. We'll common denominator this and find out that b must equal to 7/3. And so our equation is y equals to 1/3 x plus 7/3. Okay. I think that's good enough for now. I know there's still 3 pages to go, but I'm going to stop this video and come back and make another one for it. Okay? I'm tired. I think you might be too.